So today, class, we're going to begin investigating theoretical concepts associated with hypothesis tests. We're going to look at kind of what can go wrong, what the consequences of those different types of error situations are, and continue from there. If you're watching this video and you weren't in class, just a couple notes, so bear with me, class. You definitely want to work on your 21 reading guide over the weekend. Don't come to school next week not having that done. That's going to be a big problem.
Ruby Pacheco to Student Services, please. Ruby Pacheco to Student Services.
This is one of the deeper chapters in the book, and you definitely want to look at that and finish that up over the weekend so we can talk about it on the same page next week. Alright, so let's look at this issue of type 1 and type 2 errors. So first we've got a situation here that we're introducing. So it says we've got water samples that are being taken for cooling as it's discharged from a power plant into a river, okay? We've determined that as long as the mean temperature of the water coming out of that power plant is at most 150 degrees Fahrenheit, we won't have any negative effects on the ecosystem. So to investigate whether the plant is in compliance with these regulations that prohibit temperature above 150, we're going to take some samples. Yeah? So it looks like we're going to take 50 samples. We'll do that randomly throughout the day and we'll record the temperature. So the following data, after we get those 50 samples, we're going to use that to test these hypotheses. They've already given us our hypotheses even here. So we're going to look at the real mean. We'll first assume that the real mean temperature of the population, where this water is coming out in this specific spot. So our population of interest here is like water temperatures at this specific spot in this river, if that makes sense. It's not like all rivers or anything like that, of course. So we're going to say, we'll assume nothing funny is going on, nothing damaging, and it's 150. We're, of course, interested in investigating if it's more than 150. That's pretty clear here, right? We're worried about it being too high for various eggs of fish and amphibians and things like that, possibly. Okay? So what we're going to do, instead of actually conducting the hypothesis test here, because we don't even have the sample mean or anything, right? We're focused on what can happen. What kinds of errors could possibly happen with a probability test like this? So, well, I put that in a little sample here. So what could really be the actual situation that we're confronted with? Well, first of all, our null hypothesis, it could actually be true or it could actually be false, right? We don't necessarily know that when we're collecting our sample, because if we did, then why would we be collecting our sample in the first place? So either one of those scenarios could be in fact true. What we might do after running the test is we might reject H sub O and say there's sufficient evidence to suggest that the temperature is higher than we thought. Bad news for the fish, if that makes sense. Or we could fail to reject H sub O. We could say, well, we don't really have enough evidence to suggest that the water temperature is different than 150. Does that make sense to you guys? That creates 4 different scenarios of what could happen. So what we're going to think about today is a little bit of terminology for those scenarios, and we'll also start thinking about consequences for different scenarios based on what we do and what happens. So I thought we'd define some things first. So type 1 error. What is type 1 error? Well, type 1 error is this situation. Type 1 error occurs when we reject a, in fact, true H sub O, because that's an error, right? If H sub O is in fact true, but we reject it.
Ruby Pacheco to Student Services, please.
So when we reject a true H sub O, that's of course an error. That's what we call a type 1 error. And you can't mix these up. Very important. Can't mix them up. These are 2 very different things. What's the other error that could possibly happen? Can you guys describe that to me? What else would be an error out of those 4 combinations? Exactly, we failed to reject a false H sub O. You said it well, Logan. So when we fail to reject a false, an H sub O that is in fact false, that is what you call a type 2 error. Okay? So I'm also going to write a couple other things in the margin here off to the side with type 1 error. Type 1 error has a symbol. You've seen it already. Think about it. We have discussed this symbol in the homework just a second ago. If you reject a true H sub O and your alpha level was 0.05, you have a 5% chance of doing that when you picked that alpha level of 0.05. So in other words, a type 1 error is associated with the symbol alpha. Okay? So let's put that. Alpha. Alpha is the probability that we commit a type 1 error. So if you're really worried about a type 1 error because the consequences of that for your situation are quite bad or dire, then of course what do? You run your hypothesis test with a smaller alpha because you have control over alpha entirely. You decide what level you're going to reject or not reject at. You have control over that. That's a empowering thing in statistics. So a type 2 error has a symbol associated with it as well. I don't think we've seen it this year yet. Surprise, surprise, it's called beta. So beta is the probability that we commit a type 2 error. Beta is a little bit more complex to calculate. You don't have necessarily as much control over it, but you kind of do. So we're going to have to think about that for a little while here. Okay? Calculating it, though, is not as simple. Alpha, when you do a test, you know what it is because it's the level you picked. The key to understand about these two things that I want to write just kind of a note, so I'm going to say note. One key to understand is that alpha, I'm just going to write it like this. Alpha and beta are, in fact, inverse quantities. So if one goes up, the other goes down. Vice versa for both. I think that has to do with what we talked about with confidence intervals at the very beginning of inference. If you sacrifice confidence, you can gain accuracy. If you sacrifice accuracy, you can gain confidence. This is a give and take relationship just like that with alpha and beta. Okay, we're also going to talk about power, but before I do that, I kind of wanted to fill in this table up here. So if we reject a true H sub O, is that good or not good? Not good. I'm unhappy. That is not good. An error has been committed. Which type? Type 1. This is type 1. If H sub O is in fact false and I reject it, is that good or not good? Yay. I'm happy. I've made the correct decision. I just think this is kind of making it a little easier to understand. So if H sub O is in fact true and you fail to reject H sub O, is that good or not good? I agree with Sean. Yay. I've made the correct call here as well. And if H sub O is false, but I fail to reject it, I kind of gave it away because I said but. This is not good. My English is not the best today. An error has occurred. This is obviously a type 2 error. Okay? So I think that kind of makes it clear that there's actually 4 things that could happen. Of course, you don't want an error to happen, and most of the time an error doesn't happen, but they can happen. So we'll talk about another scenario and some consequences here in a moment. Before we do that, though, let's talk about power. We'll get into more about power next week, but you guys are also going to start reading about it this weekend. But I'm going to give you some pointers before you do that. So power has to do with these error types. The ability to detect differences when those differences actually exist is called power. That's what power is. Power is your innate ability with your test to figure out that something is unusual if there's actually something strange or fishy going on. Does that kind of make sense to you guys? Sometimes you don't have a lot of power. It's really hard to tell that something fishy is going on because those criminals have done a really good job of hiding it. Sometimes that's the way it is. It depends on a variety of circumstances. So what does power depend on? Some of these are more intuitive. Some of them I think we'll have to have some experience with. Power depends on, I think, three main things. Here's those things. When alpha increases, power does what? If you increase your alpha level, in other words, if you go from the 1% level to the 5% level to the, God forbid, 10% level, does your power to see things increase or decrease? This is a little tough to think about at the beginning. Power increases. Once you have this whole, these all go with each other. Once you have them all in your head, it'll make sense, but it takes a little bit of time, I think. And when alpha decreases, let's say when alpha, I'm going to go steal this. Alpha decreases, power decreases. Let's see if we can think about that with our knowledge of confidence intervals, just to think about it right now. This is one of the trickiest ones, though. Well, let's try to be real specific. Okay, so if we went from a 95% confidence interval to a 99% confidence interval, what's going to happen? 95%, 99%. Which one's wider? These are all rules of thumb that we need to eventually build in. I know they're difficult here at the beginning. So 95%, we're 95% sure, we're 99% sure. If we're 99% sure, then the net's got to be bigger, right? For us to capture the real thing. So at 95%, alpha is, actually it's 0.025 because it's two-sided, but you got to be careful about this, okay? So we'll just say 5% for now. 99%, it's actually 0.005, but we'll say 1% for now, okay? So how does that relate to detecting if there's actually differences? So we're going to keep thinking about that one. It seems like you guys need a little bit more time. So let's think about what else could affect our power to actually see if something unusual is going on. When sample size increases, what do you guys think? This one's obvious. When sample size increases, is your power going to go up or go down? Your power grows up because you're seeing more of everything. So of course, if there's something unusual going on, you're more likely to see that as well. Okay? So power increases, and vice versa. So sample size goes down, power decreases. I think that one's pretty obvious. The other thing is this. I think this one also makes sense. Maybe not as obvious as the second one, but I think you guys will be okay with it right away here. So when differences, I'm going to say it this way, hypothesis versus the true thing, when that difference is big, I'm going to say it like this, when the difference between the hypothesis and the true thing is big, what do you guys think? You have a lot of power or not very much power? If there's actually a big difference between what you guessed and what the real thing is, are you going to be able to figure that out or not? Yeah, you're probably going to be able to figure that out because there's a big difference. Does that make sense? So in other words, you have a lot of power. Large power. But when the difference between what you guessed or what you obtained with your sample, right, and the true thing that's actually the parameter value, if that's small, if in other words p hat is really close to p, do you think you're likely going to be able to figure that out? I don't think so. That's going to be small power. Now you might be able to figure it out but it depends on your choice of alpha. So unless you picked like a really tight alpha, like 0.001%, you might not get it. Does that make sense? So that'd be high likelihood of an error there. So I had one more note here to clarify in high school, so I'll write that down for you guys as well. I like it. I just clarified this in other words. This is something you should, if you haven't figured it out already, do for yourself a lot in this class. And in other classes. I said when the difference between our hypothesis and the truth is big, we obviously will have a greater chance of detecting that difference. So that's just kind of a rephrase of what we just said, if it helps you. Okay, I also wanted to say one last thing up here. We had a symbol for type 1 error, which is pretty simple, alpha. Type 2 error is this other weird thing from somewhere. It's the inverse of alpha. It's called beta. Power also kind of has a symbol. So power is usually referred to with like a big star. So this is a small star. I guess I could make its font larger. So its symbol is sometimes called star. I don't really know why that is, but there's a larger star. So that means power. And that's going to be equal to, mathematically, power. If you can figure out beta, you can figure out power exactly, which we're pretty much never going to do in this class, but I'm just mentioning it for theory's sake because that's what this chapter is all about. You get it by going 100% minus beta. Why is that exactly? I think you guys are going to need to read chapter and then come back to this and think about it a little bit first. And we'll talk about it more next week. Okay? So that's pretty theoretical. Let's look at another concrete example or two before we leave off today. So I had another one. Just put this on the back. I didn't have time to type it up. I was time crunched today. I was pulling out all the plugs to get everything done. So here's an example I thought of. You can write it down if you like, or paraphrase it. So I thought, suppose that we establish the national average of people who smoke. And after doing some kind of research on that, we think it's 18%. We're pretty sure about it. We have reason to believe that the number of teens who smoke is less. That's what we think, at least. So I wanted not to perform any tests today, but just to talk about the hypotheses and the errors and the consequences of those errors. Okay? So what are our hypotheses in this situation? What's our null hypothesis, or H sub O? Help me out. This is a parameter one, right? We got 18%. Is 18% p hat or p? It's p. Why? Because that's our baseline. That's what we think the actual value is. Okay? Our alternative hypothesis, or H sub A. What do you guys think? I think it says it in there. Less than one tail. There we go. Pretty simple. Let's talk about a type 1 error in context. And this is kind of how your problems are going to go this weekend. So what's a type 1 error in context? So first of all, do it without context, without looking at your notes as soon as possible. Type 1 error. Do we reject or fail to reject? We rejected. So that's how I'd remember it. A type 1 error is the rejection. But it was a rejection even though it was true. So we reject a true H sub O, right? So let's say that. We reject H sub O. I'm just going to write it as ho. We reject H sub O falsely. You can say this all kinds of ways, but the key is to get context here. So what did we really do? I said this. We are saying that the students, I should say teens, right? The teens, because some people might not go to school, unfortunately for them. We are saying that the teens smoke less, more, 18%, what? Is it two tails? If we reject it, then we're going to say we have evidence that the teens smoke less than, right? Because we suspected less than, not more than, Logan. Yeah? Now, it's of course possible that teens smoke more than, but we have evidence. We think that the teens in our community are good, law-abiding citizens. They don't smoke very much. That's why we're thinking about that, right? So we're saying that if we reject, we're saying that teens smoke less than the national average. Here it comes. You ready for it? When, in fact, they don't. It depends on what we set up here. So if we had reason and we're doing a one-tail test for below and we reject, then we got a small p-value with whatever p hat that we had. In other words, we would have had to have, like, I don't know, probably p hat, like, depends on how big our sample was, but we'd have to have, like, p hat is like pretty different from 18% probably. So we ended up rejecting, even though in fact we shouldn't have. H sub O is actually true. Actually, it's about 18% for teens as well. Does that make sense? So notice, how much am I talking to you guys during this part? Is it just because I love talking to myself? I get really tired of talking by the end of the day, I swear to God. You have to talk this out. You have to talk it out to yourself. Talk it out to your friends. That is an essential part of this process. So, let's do a type 2 error in context. So, first of all, let's just write it without context. If we make a type 2 error, then we failed to reject, we didn't reject, something like that. Don't play too far afield. But we didn't reject H sub O, or HO, when we actually should have done that. So in context, what are we saying? We're saying that the students smoke about the same as the national average, but they actually smoke less, exactly. Have a good weekend. So we're saying, in this case, if we don't reject H sub O when we should have, that the students smoke about that 18%. Now, it doesn't have to be exactly on 18%. Remember, that's the idea here. But we're saying that there's a difference when, in fact, or excuse me, we're saying there's not a difference when, in fact, there is. So you've got to say it carefully. So we're saying that students smoke about the same as the national average when in... Let's be consistent here. When, in fact, those students smoke less. They are good kids.
So what if we only do like a one tail, but then we learn that it's actually a lot over 18%?
Say again, Logan, sorry.
So what if like we do just do a one tail under 18%, then in the end we find out that it's way over 18%?
Then we were terrible statistics students to begin with. And if you're at all uncertain on that, you should do a two-tail test. And then this will work out perfectly. That's a great question, though. Very good question. So that would also be like a possibility for error, right? Like that's another error possibility. So you want to be careful about selecting your hypotheses, especially for you guys when you start working on your project, which I'm going to give you specs on like in a week or two, so you'll have enough tools to be able to actually start doing it. So I'm going to be careful about that. Good question. Good question. Yeah, it's a team thing. Yes, projects will be in teams if you didn't know that already. You'll have at least one, up to 2 partners if you like, but that's the max. Okay, so I want to talk about the consequences of this one before we leave off with this video today. So what is the consequence of committing a type 1 error? Sometimes a type 1 error is worse, sometimes a type 2 error is worse, sometimes it depends on who you are and your interests in the problem. So what are the consequences of type 1 in this scenario? We're saying that teens smoke less than the national average when in fact they don't. What do you guys think? Help me out. Yeah, I think that makes sense. Anybody say it in a different way? So more teens are smoking, right? What would be bad about that? Well, with us saying, what would be bad about with us saying that less teens smoke when in fact more do, basically, because that's what's happening here.
We take less preventive action. We should be taking more.
Love it. Perfect. Let's do it. So I'm going to say this. Logan said, students, we take less preventative action than we should. That was very good. So I said this, basically what Logan said. I said, I'm going to make this bold so we can see clearly here. Students requiring help may not get the help they need because we are underestimating the problem. Does that make sense? You could say that a variety of different ways, but I think that's good. We don't get people the rehab they need. What would be another consequence of that? There's probably more than one consequence of this. I mean, this might also impact the healthcare system long term. You could say that, right? Like long term, there might be more cases of things like lung cancer, and hence our hospital system might be unprepared for this greater number of cases of lung cancer. Okay? Now you might think, oh, who cares about that? But hospitals devote money in certain ways, and actually this will be a big problem, depending on how bad our underestimate was. Okay, consequences of type 2. So type 2 error, again, let's review. We are saying that students smoke about the same as the national average, when in fact those students smoke less.
Too many smoking bad classes.
Yeah, we spend too much money.
We bore students and spend too much money recruiting people with, oh, I'm about to get political here. If this is on YouTube, I'm going to get in trouble. With recruiting, let's see, to spend too much money recruiting people with exercise science degrees to teach our health classes. You guys aren't going to take this beyond the classroom, right? Okay, what else? Basically, money is being wasted on these students. Okay, you guys get the idea? One last thing on this before we leave off today. I think we have enough time to get to that other example as well. Just like I was telling the class, the quiz on Monday will have one hypothesis test and one confidence interval. You'll be asked to combine those. You definitely want to look at our video on hypothesis test number 2 at the end so you're clear on that, because that's what I'm going to do with these guys last today. But before we do that, here's the classic scenario. H sub O, we have a criminal. H sub O, they're innocent. H sub A, they're guilty. What's a type 1 error in context? We assume they're innocent, right? This is America. Assume you're innocent until proven guilty. What's a type 1 error of the hypothesis test of the trial? Assume you're innocent, right? This is America. So if we commit a type 1 error, what happens? We reject H sub O, right? We reject H sub O and hence say they're guilty, when in fact they're innocent. Consequence, we send an innocent person to jail. Type 2 error. We failed to reject H sub O. In other words, we say they're innocent, but in fact they were guilty. Consequence? OJ walks, exactly. We let a guilty person off the hook. Now, which one of those is worse? It depends on your perspective. If the crime is mass murder via chemical weapons, type 2 might be worse, depending on how many chemical weapons this person has. If it's petty theft and we send them to jail for 50 years, that's definitely worse. So I guess, how would you make a decision on your alpha level here? You'd have to say what was their crime and what are the consequences of each error. So that's where I'm going to leave off today. I'll see you next time.
Stop looking.